Assalamu alaikum dear students, I am your teacher Dr. Humaira Banu and this lecture is related to observation and calculations of an experiment. The title of experiment is Determination of Nickel in the given sample solution. The chemical equation involved in this experiment is nickel Ni plus 2 ion will react with DMG dimethyl glyoxime in the presence of ammonium hydroxide, also known as ammonia, and as a result strawberry red precipitates of nickel DMG complex will form. From the chemical equation, you can see that 1 mole of nickel is equal to 1 mole of nickel DMG complex. So the mole ratio between nickel and nickel DMG complex is 1:1. We will use this mole ratio in calculations. Observations. First of all, we will report total volume of sample solution and it is equal to 10.0 ml. Then weight of empty G4 sintered glass crucible, suppose it is equal to A gram. Weight of G4 sintered glass crucible plus weight of precipitates of nickel DMG complex is equal to B gram. Weight of precipitates of nickel DMG complex can be calculated by using this relationship B minus A, and suppose it is equal to C gram. The molar mass of nickel is equal to 59 gram per mole. Molar mass of nickel DMG complex is equal to 289 gram per mole. Molar mass of nickel sulfate heptahydrate is equal to 281 gram per mole. We will use these molar masses in calculations. Now calculations. The first object is calculate the amount of nickel in the given sample solution in gram per 10 ml. From the chemical equation, we know that 1 mole of nickel DMG complex is equal to 1 mole of nickel. This is actually the mole ratio between nickel DMG complex and nickel. Now, by definition, mole is gram atomic mass, gram molecular mass, or gram formula mass of an atom, ion, or molecule under consideration. So instead of writing 1 mole, I can write here 289 gram of nickel DMG complex. This 289 gram is actually the molar mass of nickel DMG complex. Okay. Same here. Instead of writing 1 mole of nickel, I can write here 59 gram of nickel. This 59 gram is actually molar mass or atomic mass of nickel. So by using the definition of mole, now we have this relationship 289 gram nickel DMG complex is equal to 59 gram of nickel. Then 1 gram of nickel DMG complex is equal to 59 divided by 289 gram of nickel. We have C grams of nickel DMG complex, then C grams of nickel DMG complex is equal to 59 divided by 289 multiplied by C. If you multiply, divide all these values, suppose the answer is D, and this D is actually gram of nickel present in 10 ml of sample solution. We can write this in the form of a sentence. So the amount of nickel in the given sample solution is D gram per 10 ml. Next object is calculate the amount of nickel in the given sample solution in microgram per deciliter. This is microgram and this is actually deciliter. Okay. So the starting point is, up till now we know that D gram of nickel are present in 10 ml of sample solution. Write this in the form of a sentence. 10.0 ml of sample solution contains D gram of nickel. Then 1 ml of sample solution contains D divided by 10 gram of nickel. We can calculate grams of nickel in 1000 ml. So 1000 ml of sample solution contains D divided by 10 multiplied by 1000. If you multiply, divide all these values, suppose the answer is E, and this E is actually grams of nickel present in 1000 ml of sample solution. Next step is to apply this conversion. We know that 1000 ml is equal to 1 liter and it is equal to 10 deciliter. So by applying this relationship, we can say that E grams of nickel are present in 1000 ml, or we can say that E grams of nickel are present in 1 liter, or we can say that E gram of nickel are present in 10 deciliter. Okay, so now I can say that 10 deciliter of sample solution contains E gram of nickel. Okay, so then 1 deciliter of sample solution contains E divided by 10 grams of nickel. Okay, so actually in the object we have to calculate in 1 deciliter. That is the reason why I have calculated in 1 deciliter. So if you multiply and if you divide, if you solve this, E divided by 10, suppose the answer is F, and this is F is actually gram of nickel in deciliter, 1 deciliter actually. Okay, next step is to convert gram into microgram. See, the dark one or the bold one is actually the relationship between gram and microgram. 1 gram is equal to 10 raised to the power 6 microgram. Then F gram of nickel is equal to F multiplied by 10 raised to the power 6 microgram. So if we multiply F with 10 raised to the power 6, suppose the answer is H, and this H is now actually microgram of nickel per deciliter or per 1 deciliter, you can say. So finally we will report our result in the form of a sentence. So the amount of nickel in the given sample solution is H microgram per deciliter or per 1 deciliter. The last object is calculate the amount of nickel sulfate heptahydrate in the given sample solution in picogram. Pg is actually picogram per 500 microliter. Okay, so with the help of this object, we will try to learn how we can convert gram into picogram, how we can convert milliliter into microliter, and how can we find out the amount of nickel sulfate heptahydrate by using the amount of nickel. Okay, so the starting point is same. Up till now, we know that d gram of nickel are present in 10 ml of sample solution. Okay, so write this in the form of a sentence. 10.0 ml of sample solution contains d gram of nickel. 1 ml of sample solution contains D divided by 10 gram of nickel. Then we can calculate in 1000 ml. So 1000 ml of sample solution contains D divided by 10.0 multiplied by 1000 gram of nickel. Multiply, divide these values. Suppose the answer is E, and this E is actually gram of nickel per 1000 ml. Next step is to apply the conversion or the relationship between the different units. We know that 1000 ml is equal to 1 liter, and it is equal to 10 raised to the power 6 microliter. So we can say, by using this relationship or this conversion, we can say that E gram of nickel are present in 1000 ml, or we can say that E gram of nickel are present in 1 liter, or we can say that E gram of nickel are present in 10 raised to the power 6 microliter. Okay, so what we can write now by applying this conversion, now we can write 10 raised to the power 6 microliter of sample solution contains E gram of nickel. Then 1 microliter of sample solution contains E divided by 10 raised to the power 6 gram of nickel. Okay, we have to calculate in 500 microliter. So 500 microliter of sample solution contains E divided by 10 raised to the power 6 multiplied by 500. Multiply, divide these values. Suppose the answer is EI, and this I is actually gram of nickel per 500 microliter of sample. Okay. Now we will calculate with the help of the amount of nickel sulfate. If you just have a look on the formula of nickel sulfate, how many nickel are present in the formula of nickel sulfate heptahydrate? See, only 1 nickel. Okay, so just by having a look on the formula, we can find out the mole ratio between nickel and nickel sulfate. Okay, so 1 mole of nickel is equal to 1 mole of nickel sulfate. Now, by using the definition of mole, which is gram atomic mass, gram molecular mass, or gram formula mass of an atom, ion, or molecule under consideration, we can write 59 gram of nickel is equal to 280 gram of nickel sulfate. This 59 is actually molar mass of nickel, and this 281 is actually molar mass of nickel sulfate heptahydrate. Okay, so we have now this relationship. 1 gram of nickel is equal to 281 divided by 59 gram of nickel. Okay, So I gram, we have in the previous slide, see, we have I gram of nickel per 500 microliter. So this I gram of nickel is actually equal to 281 divided by 59 multiplied by I gram of nickel sulfate. Okay, so multiply, divide all these values. Suppose the answer is K, and now this K is actually the grams of nickel sulfate heptahydrate. Okay, because we have applied the mole ratio between nickel and nickel sulfate. So in this way, with the help of the amount of nickel, finally we have calculated the amount of nickel sulfate heptahydrate. Okay, the last step is to convert this gram into picogram. Okay, by using this relationship, 1 gram is equal to 10 raised to the power 12 picogram. Then K grams of nickel sulfate heptahydrate will be equal to K multiplied by 10 raised to the power 12. So if you multiply K with 10 raised to the power 12, the answer will be in picogram. Okay, so multiply this and suppose the answer is M. Now this M is actually picogram of nickel sulfate per 500 microliter. So finally report your result in the form of a sentence. So the amount of nickel sulfate heptahydrate in the given sample solution is M picogram per 500 microliter. Finally, we will compile the result of all the objects. Number 1, the amount of nickel in the given sample solution is D gram per 10 ml. Suppose D is actually your supposed value. Okay, the amount of nickel in the given sample solution is suppose H microgram per deciliter, and the last one is the amount of nickel sulfate heptahydrate. Okay, 7 is missing here. Please write 7 here. The amount of nickel sulfate heptahydrate, this is 7H2O, in the given sample solution is suppose M picogram per 500 microliter. So this is all about the observations and calculations of this experiment. Thank you.